right? There were solutions on Google Classroom. I don't know if you saw that.
No.
No? Good, okay.
Okay.
Okay, so hopefully we'll have a few minutes at the end to go over the homework and maybe start the new stuff, but we are going to do cosine today because Miss Ashley's here, she's ready to record, and we're going to get through our second kind of graph, right? Cosine graph. Okay? Okay. And then again, hopefully it won't take the whole. And no, Caroline. Okay. So have your handy dandy unit circle ready to go, as usual. And we're going to start the same way we started yesterday, which was the chart. So we're talking cosine now. We know that the sine curve looks like, ooh, not a great marker. The sine curve looks like main axis, up bump, back to the center, down bump, back to the center. So now we're going to be looking at cosine. So we've got the same kind of chart. We've got all of our main angles, right? Our favorite angles, our versions of 30, 45, and 60. And remember that cosine is the x coordinate on the unit circle. So as you're filling this chart out, you want to be looking at the x coordinate because that one's cosine. Okay? And so you're saying, okay, at 0 degrees or 0 radians, what's that x coordinate? And you're filling it all the way through. Okay? If you can do it without a unit circle, great, just to get better practice. But if you need a little help, you can have your unit circle handy. Okay, so start filling in all those common angles. If it helps, start with degrees. We know it's 30, 45, 60. You guys have a head start, so I'll go. Cosine is x. You should know where it starts, which means it has to end in the same place after we go around a full circle. Remember, cosine is positive in the A and then the C quadrant, which is 1 and 4. So cosine is negative in the other two. So your signs, as in your positive and negative, should match up. Remember ASTC, quadrant 1 positive, negative, negative, back to positive. Okay, so we're filling in all of the cosine values, the x coordinates. Okay, are we ready to graph? All right, so I'm going to do the 5 main points. The 5 main points being the quadrant points, right? The 0, the 90, the 180, 270, and 360. Those are the nice easy ones because those are the whole numbers. So I'm going to graph that. I know that at 0, we're starting at 1. Do we want to make 1 all 4 ticks? Yes? Okay. So just like yesterday, we made one all the way at the top. That's fine. Half is halfway. This is just the basic one, so we're not going to stretch it or anything. So at 0, it's 1, which means at the ending point, 2 pi, it's also 1, right? Because that's when I go all the way around the circle and I get back to 1. At pi over 2, or 90 degrees, it's at 0. At 180, or pi, it's at negative 1, which is going to be down here. And then at 270, or 3 pi over 2, it's at 0. If you want, you can also fill in the 1/2 points, just because we do have a tick mark at 1/2. So those would be the ones right before and after 0. Right? See that? There's a 1/2 and a negative half. So I could, if I wanted to, just to make a clearer, better, more accurate picture, I could graph the 1/2s, which are right before and after 0. So there's the 0, right before, right after. And in my case, 1/2 is 2 tick marks. It should be curvy, just like yesterday. It's very similar to sine. It's not a V. Okay? It's more like a U. But it's a U that like kind of levels at the top, right? So because we know it's going to repeat, right? We know that it's going to repeat, so it's got to sort of be ready to turn around and go back down, which is why at the top here it's not straight. It's not like it's going to keep going up. It's not a parabola. We know it's going to turn around and repeat, right? Because it's cyclic or periodic. So I've got to like get my graph ready to turn around. Does that make sense? It's going to come back. And really, isn't this similar to the sine graph? The sine graph was a top bump and then a bottom bump. That's how I like to describe it. Well, isn't this sort of like starting here, right? Starting at the top and then going down, and then it's going to come back up. Because we know that's what happens with sine. So if I graphed out multiple cycles of sine, won't I essentially see something very similar to multiple cycles of cosine? They're just going to be shifted a little bit. Does that make sense? Okay, so what's the period here? How long until I repeat my whole picture? 2 pi, right? Because just like with sine, when I go around the circle, I'm going to go around again, I'm going to get the exact same values again. 2 pi. It's the same thing. What's the amplitude? 1. Same thing as the sine graph. So there's still a center line. It's not drawn in, it's kind of invisible, but there's still a center to my graph. So if there's a center to my graph, of course there's a center line. There's still bumps. There's still a bump above and a bump below. And that bump still has the same height, right? Height of 1. So there is an amplitude. What are the maximums?
0, 1, and 2 pi.
Right, 0, 1, and 2 pi 1. In this case, there's 2 maximums, right? Because I'm starting at the max and then ending at the max. And then what's the minimum? Louder, Kelly. Or pi negative 1. Great. Okay, so this is the parent cosine graph. This is the basic, this is the original. So if I want to compare the original sine to the original cosine, right, if I sort of line them up together, they both have a center axis. They both are like a wave above and below. They're both going to take 2 pi to finish, but it's just a little bit off sort of where things start, right? So this starts at the max and ends at the max. Sine starts at the center line and comes back to the center line. But both are cyclic, so if I repeated a full cycle for both of them, I would get back to where we started, right? That's just going around the unit circle yet again. Does that make sense? Okay, so now we're going to shift it. We're not going to use Desmos on this one because we saw yesterday what the A, B, C, and D values do. And they are the same thing whether it's sine or cosine. It's just obviously you start with a different original graph. So let's look at what's going on here. What kind of values do I have? What do they represent? How are they going to transform my basic cosine graph? What do you see? Natalie?
Well, like the one, when you're adding one, that's gonna move the that's gonna move the amplitude up one, like the center line.
It's gonna move the center line
Yeah.
up. Good. Okay, so this is a vertical shift, up one. We can say the center line moves up one, right? Because the center line starts at the x-axis, but now that up one is a shift up, so the center line moves up. What else happens? What does the pi over 2 or the 2 do to Jim?
The pi over 2 moves the graph left by pi over 2 radians.
Great, left shift. So just like with a parabola or a circle, when I have like x plus pi over 2 or any sort of on the inside with that, that's a left right, and we know because it's plus it's going left. Good, so it doesn't stretch it any, it just shifts the whole thing left. And then what about the 2 in front? What kind of dilation? Vertical dilation. So it affects the, what? The amplitude? No height.
The period?
Not the period, it's gonna make my graph taller, right? So if I have a normal sine graph, cosine graph, the height of the bumps are gonna be twice as tall, and sort of the depth of the bump is gonna be twice as deep, right? So it's vertically stretching, but it's not going anywhere, at least not yet, not until I do the other ones. But that vertical dilation just stretches it so that it's twice the amplitude. Okay, so let me draw in the normal one first, and then we can talk about stretching and shifting. Okay, so the normal one is a U shape, right? And it's gonna start at the 1 and then come back to 1. So I think in this case, can we just make 1 tick mark 1 rather than 1 tick mark a quarter? So this will be 1, 2, 3, 4. So it's gonna look a little different from the one above just because the scale is different. So I know my normal regular cosine starts at 1 and ends at 1, and halfway it's at the bottom, which is the negative 1, right? So I know the overall shape is a U. Start at the top, go down, come back up. And then obviously if I'm starting at the 1 and ending at the 1, halfway is the bottom. So that means in the quarter points, right? This is like your 5 main points, those are gonna be on the center line. So it's top, center, bottom, center, top. So there's your U. I know it looks a little bit different from the one above, and that's just because the scale is different, but the points are the same. Okay. All right, so let's stretch. If I stretch this first, right here, this 2, vertical dilation, where are my points gonna go? What points stay the same, if any, and what points change, if any, Jim?
The points that are on the sinusoidal axis stay the same.
Great, the points on the sinusoidal axis stay the same. So the one at pi over 2 stays, and the one at 3 pi over 2, the ones on the center line stay. Because if I stretch the height of 0, it stays 0, right? So it stays on the center line. So it's just what's above goes higher, and what's below goes deeper. All right, so this one, where's this one gonna go? To 2. So already I can see it's a taller bump. Negative 1, negative 2, a deeper bump, and then 2. I'm just drawing it dotted in because we're not done, right? That just does this, the vertical dilation. But now we need to move it. But I think I can move it all in one go. So if I'm shifting left pi over 2, on my axis, pi over 2 is 2 tick marks. So I know I'm going left 2 tick marks and up 1 tick mark, right? That's how my scale is designed. So every point is gonna go left 2, up 1. So I'm gonna take my blue graph. If you want, erase the original, just if it's too cluttered for you. So my blue graph, which has been stretched, goes left 2, up 1. Left 2, up 1. Left 2, up 1. And then left 2, up. so I erased my original, so you only see the stretched version and now the shifted version. So the green is the final, because I took the stretched version and I went left 2, up 1 on every point. Okay? What we don't see, so here, I'll erase this old one so you can see it. There is a center line. We just don't often draw the center line, but if you find it helpful, you're welcome to. That center line, of course, goes through these center points. We know that center line is at 1 because I think it was Natalie said, you know, that's what that shift does. So if it helps, you can draw in that center line, but we don't need it as the actual graph. And if we graph it on Desmos or the calculator, you don't see that center line, but it is there. So what's my amplitude? Let's fill in this stuff. 2, right? We've stretched that height of the bump. Period. How long to complete one cycle of the U shape? Still 2 pi. I did not shrink it. I did not stretch it, right? It's still the same width. I just moved it. So 2 pi is still my period. Maximums?
Negative pi over 2, 3.
Comma 3, great. So we just kind of look at the graph, right? It's not that you have to be able to calculate the max in your head based on the equation. We're just looking at the graph, okay? And
3 pi over 2.
3 pi over 2, comma 3, good. So 2 maximums for cosine in one cycle. Minimum,
Pi over 2,
-1. And then I think we kind of answered these. So our horizontal shift we know was left pi over 2. And I know our axis was up 1, or you could say 1 equals 1. So what the most important part for graphing are those 5 points, right? Like your maxes, your mins, your center points. You know that I did not graph the coordinate for like √3/2 or 1 over or √2/2, right? Because the main points are these 5, right? And of course we want to make it look nice, we want to make it look curvy, it should not be a zigzag. Questions? Okay, all right. So let's move on.